All right, so for those of you that are interested in the build of this Falcon 9 rocket, I'm going to go through, do a little walkthrough. So the idea was here originally I built a 3-inch version that was thrust vectored with the BPS Signal R2 unit, and we fired that a couple weeks ago and that worked pretty cool. I was like, oh, I'm going to scale that up to a bigger rocket. Well, we scaled it up to a bigger rocket, and then we discovered there's some limitations to thrust vectoring a big rocket like this. It's basically in the code. Anyway, so I originally built this rocket to be a thrust vectored rocket. But then when I discovered there were some problems with thrust vectoring, I was like, okay, I'll use this rocket as a level 2 rocket for my level 2 certification. So anyway, I built the rocket. It's a 7.5-inch lock precision body tube. And it has stiffeners in it too, because the body tube just not structurally strong enough to support this rocket. So anyway, the fins down here, or not the fins, the landing legs, these are 3D printed. These ones happen to be PTEG. The fins here on the rocket, the whole rocket is modeled on RockSim, and I can show you that a little bit later on. So the landing legs are PETG, and they're just for looks. They're just simply cosmetic. The rocket has fins, but I didn't want to take away from the looks of this being a Falcon 9 rocket, so it has the clear acrylic fins on it. The motor mount on the bottom here, it's a 39 millimeter tube, and then we've got the retainer that is a retainer for the motor, so that the motor doesn't come firing out the back end of the rocket. And the motor mount here is glued in with Titebond 3 glue. This is epoxy-don, and then the fins here are epoxy-don with a slow cure epoxy to create kind of a fillet here. So that's the body tube. These decals are actually off of eBay. There's a lady on eBay that prints these decals. Got NASA on the backside. So this was supposed to kind of coincide with SpaceX's launch of their crew capsule. So moving up here, we've got a camera that's looking down. This is a RunCam 2. It's a high definition camera. It also transmits a video signal for our FPV. For those of you who don't know what FPV is, it's first person view, and I'll tell you about what first person view is here in a minute. This over here, everybody's been asking about this. What is this thing over here? This is a linear 1.3 gigahertz antenna. This is how the video that's being generated in the electronics bay here is sent out so that we can view the video real time back at the where we have our base camp set up on the video screen. If we take a look inside the rocket here, on the top here we have a GPS receiver for telemetry, and then inside here we have all of our electronics. We have a 12-volt battery in here, a LiPo 12-volt battery. We have a vector flight computer, which simply, that's all that vector flight computer does is give us our OSD for purposes of altitude and telemetry. And then here we have our 1.3 gigahertz video transmitter. I think that one I put in here is a 400 milliwatt. And then also you can see these T-nuts that are installed here all around. The mount back here for the electronics is just a 3D print, and it's kind of sandwiched in there with the body tube. So this body tube sandwiches that plate in there, that mount. Anyway, rotating the rocket around, we got 2 different switches here. This switch here, when I turn it on, and everything's connected, so it'll turn on. This starts up all the primary it starts up our flight controller, and that's it. So that allows us to get the GPS initializing. It's a low heat item. Here in Arizona, it's hot and heat is a problem. So one of the things that I like to do is run my video transmitters on a separate power switch so that we can let the flight controller boot up, get GPS acquisition, and then just before launch we can turn this button on. It always scares me to turn this button on because it's also connected to our Pyro channel. But obviously I've got the Pyro channel disconnected from the rocket, so I'm safe there. This also turns on. Below this, right here inside the rocket, is our thrust vector computer. Now, I'm not using thrust vector on this rocket, but I am using some of the functions that fire the pyros on this rocket. So it still fires the pyros, and it'll still do abort criteria, which I happen to have the abort criteria on this rocket set at like 60 degrees out of the z-axis. It'll blow the parachute. So that's that. So stepping up from there, this is basically the midsection of the rocket. This gets plugged in down here. These are our leads to our Pyro channel. So there you see the two pyros, and those are what ignite to cause our parachute and our nose cone to separate from the rocket. Here's the grid fins. And these grid fins, I think this was an M5 screw, and those basically just get screwed in right here on the rocket. And they go into these holes right here. So when this is in place on here, let's see if I'm able to do it. Yep. So when that's on there, oh, better turn this stuff off. I'll line it up here real quick. Maybe. Anyway, when it's all lined up, these just get screwed in here to give the rocket the look of a Falcon 9. So that's that part. The next part that goes on top of here is this part. And this one is just a 7.5 inch tube. It's empty because this is what houses the piston. Goes in here like this. So the piston gets installed in here like this. And when the ejection charge blows, it causes the piston to come firing out the top. The piston, on top of the piston here is our parachute. So this is a 10-foot parachute that my wife sewed up yesterday. 10-foot parachute to hopefully safely get the lower stage back down safely. On top of this then is our nose cone. And I don't happen to have a 3D printer that's big enough to print this nose cone, but our friend Nate here, he has a 3D printer that is capable of printing. I think he has a Creality. What do you have, Creality?
Creality Under 3.
Creality Under 3, and it's got a nice big enough print bed that we could get this one printed. We have a Flash Forge Finder and we have a Kitty Plus, but the print bed's not big enough to print something like this. And even Nate's Creality printer, we have to print this in 2 sections, actually 3 sections: the nose, the midsection, and then the collar. Now, something you might notice here, when we launch this rocket, the nose cone actually comes down separate. It's not attached to the main body except for by the coupler, or actually this is called the shoulder of the nose cone. So this parachutes down separately on a 48-inch parachute. The blue tape here is just to snug it up nice and snug with the body tube right here. What else can I tell you about this rocket? I think that's about it. I guess I could cover the motor. The motor that we're using for this rocket. So this is the motor that we're using. It's a J435WS 14A. Has a average thrust here of, the average thrust on it is, let me see what the average thrust is. Total impulse is 737, so 737 Newton seconds of force, but I don't think that's the average. Wait, let me find the average thrust. Peak thrust is 607 newtons. That doesn't have the average on here. But anyway, so that's the J motor for this rocket. Anyway, that's it. Hopefully we'll get this launched here sometime in the next month or two. We might wait for a little bit cooler conditions. Today out at the launch site, when we went to launch, we had, it was pretty hot. We didn't get to launch this today because of a couple of reasons. We had a fire at the launch site, and after they had the fire, that delayed us by about 45 minutes, and then it raised some concerns about fire issues. So we did not get to launch Nate's 5-inch Falcon 9, and we didn't get to launch the 7.5-inch Falcon 9 because the range officers were concerned about the fire hazards. And then also these being scratch-built rockets and not kit-built rockets, and having a degree of uncertainty there, they didn't feel comfortable launching these rockets today. So stick with us. We'll get these out pretty soon. We'll get these launched pretty soon. Hopefully, like I said, in the next month or two. Thanks, guys.